All right, we have arrived. The last problem of practice exam 4. So we want to find the length and the slope of the tangent at each point to this polar curve r equals 2 sine theta. We saw earlier that this polar curve is in fact just a circle with diameter 2, so with radius 1. So either way, we're just going to go ahead and do the computations, right? So for the length of a polar curve, I need to integrate from the smallest value of my parameter to the largest value of my parameter. So 0 to pi, in this case, that'll make us traverse that circle 1 complete time and no more. And I need to integrate the square root of the derivative of r with respect to theta squared plus r squared. So I need to find this quantity dr d theta, and so that's what I'll do first. So dr by d theta is, in this case, I just need to differentiate sine theta with respect to theta. And so this is going to be 2 cosine theta. Okay. And so then now I just need to go ahead and combine all of these terms. So I need to look at dr d theta squared plus r squared and then take the square root of that. And then I'll integrate this quantity once I find it. So this is going to be dr d theta squared is going to be 4 cosine squared. So I'll just go ahead and write it like that. And then r squared is going to be 4 sine squared. Okay, so I'll just go ahead and write it like that. And then I need the square root of this quantity. Well, there's a common factor, 4, which I can pull out of the square root as 2. And then cosine squared plus sine squared just equals 1. So if you really want, you can write a square root of 1 there, but this is, of course, 2 times square root of 1 is just equal to 2. So my integrand actually completely reduces to a constant 2. And so the length is just given by integrating from 0 to pi of 2 with respect to theta. And so, of course, this is just 2 theta evaluated at pi and at 0, and taking that difference. Value at 0 is 0. And the value at pi is just equal to 2 pi. Okay, so this is the length, and that makes sense because this circle has radius 1, like I mentioned earlier, and we know that a circle with radius 1 has a circumference 2 pi, and that's exactly the length that we just found. So this is not a surprising result. Okay, and so now for the tangent. So the slope of our tangent is always given to us by the same thing, dy by dx. We have an equation for dy by dx in the polar curve case. And the way it works out is we have dy is equal to dr by d theta sine theta plus r cosine theta, essentially just by integrating with the product rule. X, the derivative with respect to theta, is dr by d theta cosine theta minus r sine theta. Again, just integrating using the product rule. And so we already know dr by d theta. We already know r, of course. And so we just go ahead and substitute these quantities. So dr by d theta is 2 cosine theta, so times sine theta, plus r is 2 sine theta times cosine theta in the numerator. And then in the denominator, I have 2 cosine theta times cosine theta minus 2 sine theta times sine theta. Okay, and these actually are trigonometric identities. So first of all, there's a common factor of 2 everywhere, so I can just go ahead and cancel those out, right? Pull out the common factor of 2 in the numerator to the front, pull the common factor of 2 in the denominator to the front, and then cancel those common factors of 2. All right, and then I have cosine theta, sine theta, plus cosine theta, sine theta. So this is 2 sine theta, cosine theta, and in fact, this is just sine of 2 theta. It's a double angle identity. And then in the denominator, I have cosine theta squared minus sine theta squared, and this is in fact cosine 2 theta, again, another double angle identity. and sine over cosine with the same argument. This is just tangent of 2 theta. So this is the slope of our tangent at each point is equal to tangent of 2 theta. And so this is it for problem 9.